and we're engineering ambassadors at UConn, and we're here to talk to you about National Engineers Week.
Engineering Ambassadors is an outreach organization to raise awareness about engineering and what engineering is and what engineers do. And this week we're doing Engineers Week on campus, trying to educate our community about engineering and how that applies to the greater world and what an engineer does with their job. In 3D printing, what happens is there's a CAD model, and that CAD model is taken and it's sliced into 2D layers, and that's an STL file. And that STL file is sent to the printer, and the printers that we have for Engineering Ambassadors has 2 tabletop 3D printers, and they use plastic as the material. And what it does is it deposits that material with what the STL file sent it. So if you think about a log of salami, and you slice it into really thin layers, when you pull it apart, they're all different kind of 2D layers, but when you put it all together, it's that 3D object. So it'll deposit material, and then the build plate will drop, and then it'll deposit material, build plate will drop, until you've printed the part that you've sent to the printer.
Come on. You do it. You do it. Careful.
If you're going to take a step, be sure not to lean in any direction on your feet.
So Alex,
The left foot on the other.
Don't lean.
Yeah, don't lean. Just try to
so
make.
I can always bring it back.
Yeah. All right. All right.
So one of the cool demos we did this week is walking on eggs. When you think about an egg, you might think that it'll break under the simplest amount of pressure because it's easy to crack. But actually, the structure of an egg is a lot stronger than you might think. It's similar to the structure of an arch of a bridge, and all of the pressure that's forced onto the top of the egg is dispersed throughout the entire egg, so not one single point is taking the full force of the foot on top of the egg.
There you go.
Oh, you did.
Oh gosh. The word hydrophobic actually means water-fearing, so this sand will not get wet when it touches water. You can take it out of the water and it's still completely dry.
Basically what happens is the water becomes more attracted to itself than it is to the sand, so it does not cling to the sand like it does with normal sand.
Oobleck is a mixture of cornstarch and water. It's a non-Newtonian fluid, which means that it's a liquid, but when pressure is applied to it, it becomes a solid. So if you put your hand in it, it'll sink down, but as soon as you put pressure on it, you punch it or something, it'll immediately turn into a solid. So what we do for National Engineers Week is we get a giant tank of oobleck, and it's about 6 feet in length and 3 feet wide, and we allow people to run across it, and we call it walk on water.
Faster.
Ow! Yo, that's crazy. There you go.
The high-level principles that we've demonstrated for National Engineers Week include pressure, force distribution, density, buoyancy, advanced manufacturing, electricity and magnetism, fluid mechanics, and nanomaterials.
Okay, so one of the engineering ambassadors really wanted to host a Rube Goldberg competition, so we're doing that on Saturday, and several schools are going to come, and we're going to have them here for the competition. And Rube Goldberg is a competition where you try and do something really simple like hammer a nail or toast a piece of bread, but in a really complicated way using chain reactions and things like that.
Set him off, knock him over, and pull down the hammer.
Marbles, it goes down into bullet bill.
Oh, wait, it's good.